Hello? Is it really time? Good morning, everyone. Welcome. Please come in. There are still a few seats left, or a couple hundred. My name is Torgersen, or at least that's how I say it in American. And I'm the lead designer of C#, work for Microsoft. And we have a new C# coming up for you. For those of you who are interested in C#, which I guess is a lot of you since you came in here. How many people here use C#? Okay. How many don't? Okay, so don't be shy, Okay, so we can be pretty insider about it. I'll lean into that. So there's a new C# coming up, C# 14. We'll spend most of our hour together talking about that. I have a host of slides prepared for you. Well, actually, no, I don't have any slides. We just spent the whole time in Visual Studio just to keep it exciting. I have an internal preview version of Visual Studio that I'm going to do things in. So if things crash and burn, that's just that. We'll just do some code. And I spend most of the time talking about the upcoming C#, C# 14, because the way I envision the next hour is I will spend a good chunk of time on the biggest feature in C# 14, which is extension members. I'll spend another good chunk of time on all the other features. And then if we have time left at the end, we'll talk a little bit about something we're thinking about for the further future. I'll still do it in Visual Studio, even though we haven't implemented it yet, because it's just more fun that way. Since we'll be doing code all the way, then it's good to take questions along the way, because if you save your question about something till the end, chances are I will have changed the code by that time or accidentally closed the window or something. So I'll stop a few times and ask for questions. I'm told there's a mic that can be run to you because there's a recording, and it's good to capture the question on the recording as well. So when I stop and ask for questions, just raise your hand, and a mic should show up to one of you, not all of you at once, but we'll figure that out. So don't hesitate to just ask questions at those points. With that, let's just go and play with C#. So let's start here. So extension methods. How many people use extension methods? Take your hand down if you don't like them. Okay. That was confusing. Okay, some of you don't actually like them. That's interesting. So we think extension methods are extremely cool. We sort of stumbled on them as we did query, language integrated query things back in, they came out in 2008. So when I joined Microsoft in 2005, we were already working on that. And there was sort of just this trick to put instance methods onto types that you don't own. And that's really cool for putting querying methods on there and getting so that you could get a nice kind of fluent flow of code, and discoverability. I have a collection, I press dot, a method comes out. That was great. And it was great way beyond what we imagined, to the point that it was probably about, I don't know how many seconds from extension methods came out until people said, when can we get extension properties? When can we get other extension things? Because it's a really cool software composition mechanism. Why is it limited to methods? And it took us 17 years, but here we are. We now figured out how to do it. And so I'll try to tell you not just like what we did, but also why it took so long and how we arrived at this design, and was sort of good or bad about it. Because it wasn't easy. We've been down many paths that turned out to be dead ends. So what I have here is a collection, and then I just took a couple of the methods that are in system link enumerable, and I just lifted them into my own static class so we can play with them. Okay, so these are just like the first extension method and the range factory method from there, and we'll just go from there. So what is the problem really with extension methods? So what is an extension method? It's a static method that masquerades as an instance method. It pretends to be, it cosplays an instance method, right? So so you use it as if it was an instance method with 0 parameters, but really it's a static method with one parameter, and actually a type parameter. And the one parameter is special. It's the receiver parameter, and that's how we say, okay, this is an extension method on this special first parameter. So we're really using static methods, the expressiveness of static methods quite intensively. We're using the fact that static methods can have parameters and that they can have type parameters to express extension methods. That's a little syntactic hack. It means we only had to add this little bit of highlighted syntax, and we had many things to add in C#3, so fine, not so much syntax. But it means that we couldn't just do the same with extension properties, because properties, static properties, they don't have parameters, and they don't have type parameters. And so we couldn't just do the same syntactic trick. It's limited to methods. Okay. And that's what we've been battling with ever since. So to show you what we decided to do, we sort of have to back out of this syntactic dead end and introduce a new syntactic paradigm for extensions. But we want it to be fully compatible with the old one. We want to be able to take existing extension methods into a new syntactic paradigm that's open to new members. So let's start there and see how we can do that. So first of all, let's remove all the stuff that is specific to that only methods can do from the signature here. So the type parameters and the parameters, and just actually leave the method as it would have looked if it was really like the method that is pretending to be an instance method with 0 parameters. And then take all that stuff that we removed and just put it somewhere else. So we introduce a new kind of thing that we call an extension block. And that one can have type parameters, and it has a single parameter that is the receiver parameter. So it has the same stuff here. And then we just say open curly, and then you can put a bunch of stuff in there that are the things, the extension members that you want for, in this case, INumerable of tsource, where tsource is this type parameter. Okay, so just move the stuff away. And what's left down here is, what the method declaration would have looked like if it had been the instance method it pretends to be. So now you can kind of see, now you can kind of guess what we're going to do for properties in a minute. But before we get there, just to keep this, the suspense is killing you, right? This is like, oh my God, where's it going to go with this? So I'm just going to drag it out a little longer. Let's first look at how this works. So this is a different syntax for the same as what we had before. How is it compatible? How can we make it so that you can move to this new syntax, but all the consuming code of your old extension method, all the people who depend on your library or whatever, they don't get broken? Well, let's talk a little bit about that, because when it was a static method, you could call it as a static method, right? So you could go, let's take this q here, which is a string, and do a query over that. We could, instead of saying q.first, we could actually say myEnumerable.first and call it as a static method with one argument, q in this case here. And that still works. That has to still work, right? Otherwise we failed in our mission. And the reason it still works is that I went over a little quick, but if I go and press dot here, you can see there is indeed a first method. There's a first method, static method generated on myEnumerable. We still generate that method. We even generate it, you can see this in there in its parameter. We even generate it as an extension method so that other compilers, like older compilers for C# or compilers for other languages and so on, they can still see that it's an extension method in the old-fashioned way. They don't have to learn about this new kind of extension thing. Okay, so we make it super compatible. Just the method you had before, and you don't have to write anymore. We generate it for you. You start from the common shape that you're going to consume an extension method with, that is the instance method. That's now how you write it as well. That's the intention. But the fallback of being able to call it as a static method if you really want to, for instance, if there's an ambiguity with another extension method, or if the receiver type has an instance method that is shadowing or whatever, like those reasons that you would call it as a static method before are still valid. Now you can still go and do it. So that's how we move you forward here. Okay? So far, so good? Now the door is open, though, to doing other kinds of extension members. So let's do it. Let's make an extension property. You ready for that? It's early. I don't know. I don't know if it's going to blow your mind. What does the property look like? Well, now that we have this syntactic paradigm of just using, I'm going to take it a little longer. Did you wonder about the source parameter here? The receiver parameter is still a parameter. If this was exactly like an instance method, it wouldn't say source here. It would say this. Right? If it was inside the class that it works on, it would say this. And we thought about this a lot, but in the end, we didn't go there for a few reasons. One of them is, it was just easier to move the body without changing it, so it's less of a change. But also, actually, sometimes people make use of the fact that the receiver parameter is a parameter, and they do parameter things with it. Like you might do ref on some of your parameters. You can't when it's a reference type, but you can when it's a value type. So it doesn't get copied, but mutations apply back to the struct that you called it on, that kind of stuff. You're allowed to do that. Maybe you have attributes on there, like not null or whatever people have been using for that. Sometimes the thing itself uses nullability annotations, blah, blah, blah. And those are all things that you want to be able to express. So there has to be a place where you can put these things on and treat it as a parameter. And we just decided, keep that. Then that all still works. Again, much easier to port to the new one. And we still have all the expressiveness you did before. So that's why the body doesn't look like the body of an instance method, even though the signature looks like the signature of an instance method. And now let's make it into a property. So what does a property look like? Now it's easy, right? Because we know how to do this. Properties have a getter, maybe. Let's see. Get, open curly, close curly somewhere. Boop. It's an extension property, ladies and gentlemen. That's how easy it is. You can now write an extension property. And do you want a setter on that? Sure. Now here comes another interesting thing. Maybe it's not interesting to you, but it's interesting to me. What about extension fields? Is that a good idea? Like add more state to an existing object. We figured that's probably a little bit weird, because extension methods don't actually, extension members don't actually modify the original class. So if we went and yanked another field in there, that would somehow violate that other class that somebody else wrote that we don't have access to. And then we could do some smart compiler tricks with some table on the side where we keep all this extra state that was added with extensions. But that gets really messy and not as efficient as you would expect if you wrote an extension field. So we don't let you do extension fields, and we also don't let you do extension auto properties or field-like events or anything else that adds state. We just don't. We don't think that's going to be a thing. If you want to do it, if you want to have a side table with state, feel free to do so, and feel free to write an extension property that accesses that in whatever way you want. But that's a bridge too far for us in the language to make decisions around how to do that, and to pretend something is cheap when it's really expensive. But so for that reason, you might not see that many setters, but it might make sense to you, and you're definitely welcome to do it. So can we use our extension property? Well, first you notice that it's not actually squiggled up here. You can still call it with parens, but that's just because the real first method is still there, not my fake one. But if I delete the parens, it's now being invoked as a property, and that works just fine. It's an extension property. Ladies and gentlemen, it's an extension property. Who all wants to use extension properties in their code? Not many. Yeah, okay, come on. This is Europe. Yeah, I know you're shy. Okay, thank you. And even like we have the setter, you could actually call the setter instead. Let's put another string in there. That works. That just calls the setter. So somehow we made extension properties work. Now, if you want to disambiguate, like we talked with the methods before, there's not a first static method generated for you anymore. So I wonder how we could disambiguate. Actually, I don't wonder because I know, but you should wonder. Let's see what we have in the completion list. Turns out that there are not one, but two static methods added. They're called getFirst and setFirst. And did you know that whenever you have a property, there's a get and a set method generated for it, well, there's a method generated for each of the accessors that you declared. If you didn't know, no surprise, because we do everything we can to hide it from you. You don't get to name them directly from the language. They don't show up in completion and so on. But the way that we generate the accessors is by generating methods for them with these names, get underscore, set underscore, and then some extra metadata saying they belong together as a property. And so it was really easy for us to say, well, let's also do that for extension properties. Instead of like for the getter, for instance, let's use that one. Instead of having an instance method with no arguments, though, we again have a static method with one argument, and it can have the type parameter as well that it can use to that we can use to pass it the type argument for the extension itself, the type argument for tsource here. So this sort of looks like another extension methods, really. Yeah, extra receiver parameter and all the type parameters. There. Okay, so that's how you disambiguate. We thought about should there be like a dedicated syntax for that, but that would quickly get us. We think, is this a little ugly? Should we not be letting you see this previously hidden method? We're like, actually, let's just do that. Anything else would be worse, we think. And if you complain about it a lot, we can do it in the next release. Right? So, okay. Does that make sense as well? Mm-hmm. Now might be a good time for any questions. We'll talk a little bit more about extensions, but I just want to make sure that the core model here is completely solid with you. Any questions? Going once, going twice. Here's one. Hang on a sec. Mike is on its way to you. Way up here. Thank you. So that the people who aren't in the room can hear him.
So yeah, I don't have a question. The only thing that I wanted to say is like we have get first, right? Mm-hmm. Why we have it lowercase and not Pascal case, for example?
Oh,
I mean get in Pascal case.
That is a great question.
Yeah,
this does not look very
like
C-sharp-like.
a C++ method, and
yeah.
I don't like that one. So
it's terrible.
Yeah.
But you know what? It's not my fault. It's a really good question. But this is the decision that the C# compiler writers made back 25 years ago, that was the name they would use for property getters and setter implementations. And we figured it was better to use the same name here to play the same role, even though we are exposing it, than to confuse people by having a slightly different name. So it is my fault a little bit, I guess, to make that decision. But that is why. It's to stay in accordance with to stay kind of regular or in alignment with
consistency.
Consistency is the word I was looking for. Thank you.
Thank you.
Great question. Okay. Any other questions before we move on? I don't see one. Yell if you have your hand up and I'm not seeing you. Okay. Let's move on then. So that's extension properties. That's also pretty useful. We don't have all the different kinds of extension members yet. We're probably going to add some more in the next release and the next or whatever. We'll kind of see what you all ask for and do them in that order. But we do have a few more. And one important kind of extension member that we have is that both properties and methods can now be static extension methods. Okay, so you can extend a type itself rather than its instances with members. Okay, so that's where this other method here from link comes in. But let's take this and collapse it so we have more screen real estate here. So we have a range method. It's kind of it produces an enumerable of ints in a range. Okay, and it's kind of tucked away in system link enumerable, and you have to know to go there to call it. But it's a factory method for enumerable of int, and that's not really an obvious place to go and find a factory method. Typically, you want to find your factory methods on types that have something to do with what the factory produces. Right? Maybe for instance, the factory method's result type itself. So let's actually go and try to achieve that. Now, we do encourage, so we already have an extension block for IEnumerable. So it would be kind of tempting to just say, let's take this, and well, that got odd. Here we go, and just put it inside. But that's not actually what we want, because we only want to extend IEnumerable of int, not all IEnumerables. So let's give it its, whoop, what am I doing here? Let's give it its own extension block that has a slightly different receiver type. So we say extension. It's not generic because it's just IEnumerable of int. And we could say source again. And then let's wrap it around here. And there you go. So it actually already looks the way we want it to look. It's pretending to be a static method, and it looks like a static method because it is a static method. So there's no transformation, there's no removing parameters or anything like that. If there were type parameters, we might have to shift them around. But it actually already looks the way we want it to look if we want to stick it on IEnumerable of int. So now we have the situation that it's still a static method, just like the instance extension method is still a static method on, wow, that's a lot of stuff. Still a static method on my enumerable. You see the range method there. It looks just the way it did before. So it's still accessible as a static method. So you can do that. And let's call it. And not call it with Q. My number, no Q here. Call it with a start and a count. Let's say 1 and 10. But now we could also go to IEnumerable of int and say, make me one of these guys, and range is there as an extension static method. So I think this pattern of having factory methods that you add to existing types is going to be really common as well. Like you introduce a new type yourself, but you want to make a new factory method for an old type from your new type. Now you can go and stick it on the old type, so it's discoverable for people who use your library but want to create the old type from it. So discoverability is the name of the game here. We could take this a little further. We have a little time. Let's make this a little more fun. Actually, having this range method just for int, IEnumerable of int, is kind of lame, right? Did you know we have generic math now in C# as of a couple of releases ago? We have an interface called inumber that prescribes all the operators that you use for numbers. So we could actually make this one generic as well. Let's call it tNumber, and make it an IEnumerable of tNumber. And then let's go and take almost all the places where we use int tNumber and turn them into tNumber. This one should still be an int because that's a count. And now we say where, just to show you that you can have where clauses on the type parameters on the extension block as well. Where tNumber is INumber of tNumber. Okay, it's a little bit of a mouthful, but there you go. And now you can see the plus plus down here operator, no longer red squiggles, because even though we don't know what the element type is, we know that it's a number, and that means it supports plus plus. Okay? That's been in the language for a couple of releases. I'm just kind of, but it's nifty, so I still want to show it to you. And now this call up here still works, but if we say IEnumerable of long instead, it still works because long is also a number, and the implementation still works. So you can kind of see, you can do some pretty nifty things now. And just the last thing I want to do is to say, well, maybe it's not, often you want a factory method on the thing that it produces, but in this case, maybe it would be cooler if it was just on tNumber. Right? You just go up to int and you say, give me a range of these guys. Kind of like how you say int.parse or something like that. And now we could just, instead of saying IEnumerable of long here, we can just call the factory method on long. And that's, if I can type right, and that's pretty nifty. Okay? If we do ulong, type inference for that type parameter is going to struggle a little bit. And we just say, okay, whatever this one is, it's an unsigned one, and things work again. Okay, so that's kind of how you can play with it. Make sense? There's also extension operators, but I want to save them a little, and we'll get to them a little later. Okay? Any more questions before we move on? All right, so extension members, on their way. We have extension methods, properties, static methods, static properties, operators. More things to follow, probably indexers, constructors maybe, but we'll kind of see what you all ask for the most, essentially. And then we'll get to work on adding those. Okay? That's the main thing in that's the biggest thing in C# 14, but there's lots of other stuff, which we'll go and look at now. So ready for a whirlwind tour of absolutely silly, meaningless code that is just all on the screen now in order to facilitate showing all the features. Okay. So here's an assignment, and here's an assignment each to a member of person, but person might be null. Okay, we get a nullable warning. Yay for nullable reference types. Who hates nullable reference types? Thank you. Who loves them? Let's talk later. Thank you for warning me that I might get a crash here. But because this is an assignment, we can't do the usual nifty trick of having question dot, because that doesn't work when it's on the left-hand side of an assignment. We'd have to go and say, if person is not null, and wrap it in that. Or I guess we could go and say, I don't care, I don't think it's null. Shut up the warning. Not recommended. But actually, why doesn't this work? Because we didn't get around to it, I guess. And this is C# 13. So let's just go and say, so if you want to play with new features, so this gives me a chance to show, go change your lang version in your project file or wherever you edit it. You could always change it to preview, and then you'll get whatever language features are currently in preview in the current production compiler of C#. Like, we release our language features as they get ready, or as we get ready for feedback on them, under the preview flag in release bits. That's how we do it. So take advantage of that and go and play with preview when the new features come out. Give us feedback and help us get it right before it's fully released. In this case, I'm actually in a preview of the full next version of Visual Studio, so I can actually say 14 here. It's already there. So that's what I'm going to do. And now, 1, 2, 3, boom. The red squiggle is gone, because now you can have null conditional assignment. It means that if person is null, not only is the member not accessed, but the right-hand side of the assignment is not evaluated, and the assignment itself doesn't happen. Okay? So the whole thing is guarded by that null check there. And now, of course, it says, well, now I don't know down here whether it was null or not, so but we can just go and do the same here. Okay? This is a pretty useful thing, frequently requested. So we just went and did that one. Out of the very small, there's medium and small features here. I'm just going to show you some of the small ones as well. Whenever there are like paper cuts that people keep running into, that are just little nuisances, we try to get some of those in every release. One of them is that lambdas, since time immemorial, have had two forms, a short form and a long form. The long form, you have to say the types, and the short form, you don't have to say the types of the parameters. But modifiers only are allowed in the long form. So shucks, if I have a delegate type with an out parameter, I always have to use the long form to assign a lambda to it. That's kind of just stupid, right? So we went and just did away with that restriction. Now you can still remove the types, and the short form also allows modifiers, and there you go. Okay. Probably just a few of you really run into this, but those few have been annoyed for years, and now you're welcome. Okay, good, yeah, kind of thing. All right. Next thing I want to mention is we've been kind of on a roll when it comes to partial members for the last couple of releases. Partial classes forever, right, have just been, I can have members of the class in one place and also in another. Oftentimes it's used, not necessarily, but oftentimes it's used for situations where one of the parts is generated by something. And we have a whole source generator infrastructure with Roslyn that is getting very nifty. So oftentimes you have a situation like this where I manually write something, and then I expect the source generator to produce the rest. And it's not just more members, but in the case of methods, it can also be partial methods where one part, like the user-declared part in this case, says there should be an unnamed change to method with this signature. And then the source generator can go and say, I got it, I'm going to implement it for you. So partial members have a declaration part and a definition part with the actual implementation in it. But up until recently, it only worked for methods. Then recently, we made it work for properties as well, because actually, you just want to say, you don't want to say this whole thing. Up here, right, you want to have that source generated, and you just, so let me just copy it, and you just want to say partial that, and it has a getter, and it has a setter. You figure out the rest. And then the pretend source generator that I don't actually have, I'm being the source generator here, can just go down here and put the partial implementation of that in there. And probably the field that it uses is also generated, and it sits down here alongside. So this is all, so now for properties, as of C# 13, which is out, you can do the same kind of thing. And we added properties and indexers in C# 13. C# 14, we're following now with constructors and events. So more and more kinds of member kinds, kind of like with the extension members before. So we can now go and take this event down here is something that you might want to say public partial event, and just have that declared, the user declare it, and the source generator produce it. And that now works. So partial got better, and some of you might make use of that. Any people use partial here or source generation? Okay, a few, okay. Most of you are like, get on with it. Okay. What else can we find down here? Oh yeah, back when we re-implemented the C# compiler in C#, we didn't have so much time to also add new language features, so some of them were a little half. That's a long time ago. Some of them were a little half-finished. Like the name of feature, when you want to take the name of, the result of name of a generic type is just its name. It doesn't say anything about type parameter. You just get the string with a name in it, but you still have to provide a type argument, and it still has to be a valid type argument. So that can be a pain sometimes, all to have it just ignored by the compiler. It just has to compile, and then and typebuff doesn't have the same problem, so this time we were just finally going like, okay, you can just say this, and you're fine. Okay? Definitely a small feature. Now let's get to something that's a little more beefy, or meaty, which is auto properties. So auto properties, again, a long-time favorite in C#. But they have a really steep cliff. We tinkered with it a little bit over the years, but an auto property generates a backing field, it generates accessors, and if you don't like exactly what it does, you fall all the way off the cliff, and you are like, you have to write everything yourself. And clearly, whoever wrote this stupid code fell off the cliff, because I wanted to also call on name changed, right? So I wanted a little extra functionality in one of the accessors, and off the cliff I go. And that's lame. And so we're fixing that. We talked about that for a couple of years, and finally it's going in. The way we're fixing this is we're introducing a new contextual keyword called field, which lets you access the generated backing field from within your own accessor implementation. So instead of name here, I can avoid at least I can avoid declaring my own field, which all the other members, of course, will accidentally use instead of the property. And I can get a little terser and a little safer by just using the field keyword, which now says generate a backing field and use it when you say field. And now I get a warning on this one saying the getter doesn't use field, but the setter does. Well, I can fix that too, and now my actual backing field is, I can remove that. So that's a little better. And this is really just an auto property. It's an auto property, but it doesn't have its accessors auto-implemented. But it's an auto property because it has its backing field auto-implemented. But it could have its accessors implemented, or some of them, because the getter just the standard thing. So I could just go and remove the body and have that generated for me, and it accesses the backing field automatically, and the other one, I do it manually. But I don't have to use still don't have to use my manual backing field. So is that useful? Can you see yourself? Do you recognize the cliff? Nod, a lot of nodding. Yep. Good. So that is finally going in, and I think that is going to be extremely useful. We're going to see a lot of occurrences of the field keyword. And I would love to stop that story there, but there's one little problem we have to acknowledge, which is field used to be a valid identifier in this place here. You know, if we go a little back and we happen to have them both implemented with field here, this is already valid code today if you happen to have something around called field, and now we're changing its meaning, right? That used to compile, field here used to reference whatever in scope was called field or be an error. Now it's a contextual keyword. So we're like, what do we do about that? We don't usually do breaking changes like that in C#, though we've gotten a little braver over the years. And what we ended up with was, let's get a little braver still. There were many, many suggestions for what syntax could we use instead of field here. And in the end, this was just clearly the best syntax. And instead of giving you a lousy syntax forever, we decided it's probably better to give you a little bit of a bump in the road as you move forward to new versions, like a one-time fix-it-up situation, rather than having a worse language forever. And we kind of regret some instances in the past where we didn't also make that choice. So we made the choice to say, actually, you know what? We're going to do what's right for the language. You're going to suffer a tiny bit for a single instance as you move forward to this new version of the language, and then you're going to be fine. But we're going to help you out a bit by giving you a warning when there's something in scope called field that you would have been referencing in previous versions, and then you can go and say, oh, I can fix that. I don't have, Visual Studio doesn't have an auto-fix for this yet, but it probably will. But there are easy ways to then go and fix it so that these still reference the field called field. Okay, so you can either say, you can explicitly say this.field, and then it doesn't mean the keyword anymore. That's how you would do it when it's value, right? If some of you ever tried to reference a thing called value from inside a setter, you already had to do this before, right? Ignore the fact that it's grayed out. That's just the IDE isn't up to date with this feature. Or you can actually say, I should remove that because we actually wanted, the other way to do it is to say, well, field is a keyword, but you can always escape a keyword by putting add in front of it, and then it's an identifier. So either of those two fixes, you can just when you upgrade to C#14, go through and address all those warnings like that. They go away, and you're good. The only situation that is a little annoying left then is that if you actually want to use it as a keyword, and there happens to be something in scope called field, and you can't change its name to something else, so that's a little annoying. You have to shut down the warning. We hope that's okay, but if we get feedback that that's too annoying, we'll come up with something. Okay? But we think we want to start here, and now this is our canary in the coal mine for, can breaking changes in C# like this, is that still okay? Or are you all going to get super pissed off and we have to, we won't be able to retract it, but then we'll learn from that and say, okay, let's not do that again. But our hope and belief, after having floated this feature for a couple of years now, is that we can move the needle and make better, more right design decisions for C# in the future, even when it has a little bit of an upgrade pain, a little bit more of a breaking change. So we hope. Actually, let's do a little quick survey in here. Who thinks that is a bad direction for C#? And please be honest, because I want to hear from you. Who thinks it's a good direction for C#? Okay, so you're all good with a little more breaking change if that's what's right for the language? Thank you. I love that. Especially, I'm a little relieved. Thank you. Okay, so let's just do one more thing in here. And this one's going to be really silly, okay? But I just want to show off two more features. So if you look in the implementation of the partial event here, I'm doing add and remove on a list. Well, wouldn't it be cool if I had an operator to add and remove elements from lists instead, right? If I wanted to, so let's say I wanted to, instead of doing this, I want to say name changed handlers plus equals value. I know this is really, really super silly, but just bear with me. And minus equals value here, okay? That would be really cool to do that with lists if I'm kind of like, I don't know, hipster coding, whatever. Let's get rid of this, get more red squiggle there. Well, let's add an operator to list as an extension operator and make this work. So let's have a static class called myExtensions here. Static class. I don't know. It should be fairly evident by now that I don't actually know how to write C#. Static class myExtensions, extension block. Remember that. We want to extend. What do we want to extend? Lists of T element. So let's take a type parameter. The receiver type is list of T element. And let's call the receiver list. Okay? And inside of this, we now do an extension operator. So can anyone remember how to write an operator? Something like public, static. We want it to return list of T element. And then it's operator plus. And that operator takes a list of T element, T elephant. And let's call that let's call that. Actually, these are static. Never mind. Let's call that elements. That's fine. Let's actually just do that thing that it's. Thank you, Copilot. That works. And then what we'll do is that we will return. Yeah, new list of elements. That's almost right. Actually, that's not right at all. Yeah, no, it's pretty good. New list of elements. This is going to be annoying. But actually, so this is how I add a plus operator, for instance. Extension, it's just the same syntax. But I don't really want a plus for lists, because that's going to create a new list and then add an element to it, and that's going to be super expensive, and calling .add wasn't super expensive. I only want to support plus equals. I don't want to support plus. But the way you support plus equals today is by implementing plus, and then plus equals automatically works. But that's not what I want here. I want to support plus equals. So instead, I'm going to leave that up here for a bit and then delete it in a second. I want to, and this doesn't just, now I showed you extension operators, but what I'm about to do next works for extension operators, but also for your own operators inside of the types, right? That is compound assignment, user-defined compound assignment. Okay, so plus equals, you can define plus equals directly. And it's a little surprising, because I'm going to do it now. Public, now I'm going to go off script here, and instead of saying static, I'm going to go straight to return type, and because this is going to be an instance operator, and the return type actually is going to be void, because we're in it for the side effect. We're actually going to mutate the receiver, so we don't return anything. Okay? So add T element, it's onto me here, but that's not what I want to do. I want to make it an operator. Operator plus equals T element. Okay? It's not happy, but that's just because I haven't implemented it yet. So let's do that. What should it do? It should take the list that we're extending, the instance that we're extending with this instance operator, and it should add the element. Full stop. No red squiggles. Let's see up here. And the plus equals is not squiggled. Is that because of the other operator here that we were doing before? No, it's not. It's because we implemented our first compound, user-defined compound assignment operator together. And it's even an extension one. So I know that I said this is kind of like a hipster. This is kind of like, do you really want that much operator stuff? But when you need, sometimes operators are just really cool. But there are cases where you really only want the one that mutates the left-hand side, where it's expensive, as in this case, it would be expensive to first create a new one, then go up to the variable that hold the old one, override it with this expensively created new one that's only a little different, and forget all about the old one. Like, that's just terrible. We have things like we have multidimensional matrices, whatever we call them. Not function. Anyway, word escapes me. Very expensive, humongous value types that we are offering for machine learning and stuff. And being able to just say plus equals on them instead of creating a new one and throwing away the old one has massive performance implications. So for that kind of situation, even if you want the plus operator, having the plus equals shadow that for those situations is really super useful. So there you go. When it's useful, it's really useful. I'm not going to fix up the other one because we're going to leave this file of code shortly. But I want to see if there are any questions about what we saw since last time I asked about questions. No? Ah, come on. I bet some of you are going to come up and ask me afterwards because you're too shy to do it in a group setting. But I promise you, your question is useful to everyone else as well. Okay. Okay. You want me to get to the post C# 14 stuff. You don't want to hold me back. That's what's going on. Okay. So with that, I may have forgotten to show you one of the features in here, but that's how it goes with live coding. Before we go to another Visual Studio window, I just want to point you to, so you saw a bunch of stuff here. I didn't see anyone take notes. You probably want to read about it again. Go to the What's New in C# 14 on our documentation website. Don't put the EN/US thing in there. Just cut that out if you want it in another language and it's going to go localized. But that's where you find that. You can see all the features I talked about, plus one more, I think, on the list here. You can go and get updated on that ahead of time. Go play with this. Tell us what you think. It's late. It's too late for us to change it, to be honest. What I'm about to tell you about, though, is not too late to change. It's still very much in the works, so much so that, as I said, we haven't implemented it yet. And if you want to give us feedback, there are multiple channels. You can just shoot me an email, mats.torgersen@microsoft.com. But also, C# language design is open source. There's a repo, .NET C# lang, that all the language design happens on. We have a language design meeting that of the C# language designers, which are mostly Microsoft folks, but not exclusively. And those meetings you can't participate in, but the notes from them, they come out publicly here. A bunch of discussion happens in here. Lots of the features we do nowadays start out by being proposed by someone in the community, someone who's not on the full-time C# team, and then they make their way through here. We couple you, if you have a proposal like that and the C# design team is like, let's look at that more. One of us will champion it, work with you to get the proposal through and so on. Several of these features come from that kind of so open source design. And this is also a great place to, it's noisy, so it can be overwhelming, but it's a great place to get kind of the first hints at what's going on next. Okay? But another great approach is to just be in the audience today and listen to me talk about it for the next 10 minutes. So that'll work too. Let me do that. Okay. This is called nominal type unions. This project here is called that. Why is it called that? It's because it's about adding union types to C#. And the way we are going to add union types, we call that nominal type unions. And I'll unpack that for you. Many of you may not have experience with union types at all and be like, what's he talking about? Then some of you will have played with some functional language like F# and be like, well, you realize that discriminated unions in many functional languages, they're the bread and butter of modeling, domain modeling. They are the inheritance of functional languages, right? Then some of you will have played with TypeScript, and you're like, oh, union types are just like these magical things that are created out of thin air all the time to say, well, I guess in this place, that could be a bool or it could be a string. Let me just say bool or string. They're just like these structural types that you can say or the compiler can infer when it knows or when you know exactly what kinds of things, maybe unrelated things, can be in a place. Okay. So you have different versions of what union types is, but we have strong and very long time feedback that a lot of people would really want to have union types in C# in some form. There's just these very different forms. So how do we choose? And this is how we chose. So we agree that there should be union types in C#. And they are for expressing situations where you can have multiple different types that may not be related. So they're type unions. They're unions of type. You say this type or that type or that type. Those types may not, they may already exist. They may be from different projects, may have nothing to do with each other. But instead of just giving up and saying, okay, it's all object, losing all type safety, it'd be really nice to have a way to capture these three types. It can be one of these three types. And the way that we choose, so that's what unions, so unions are going to be type unions of types. And they're going to be declared types or nominal types, as we say. They're going to be types with names. So you declare a union type. They aren't like, you can't just do struct, you can't just, like you can say list of int again and again, and it's the same type. You can't say list or int as a type. You have to declare something. So that's different. That's different from TypeScript. They have to be named types. And part of that is, in TypeScript, for those of you who know it, it's just a type system that goes away. The compiler takes it all away, and the types don't exist at runtime. So they're just kind of a way to give you type errors and good tooling. I say just, that's very important. But types in C# and .NET, for better or worse, and mostly for better, I think, are very different beasts. They very much exist at runtime. They are a thing that have runtime semantics. You can ask, is this value of this type at runtime, and get an answer. Right? All our pattern matching machinery is based on that. And so for that to work out, we would either have to teach the runtime a very deep lesson about union types so that they can exist at runtime, or we do something else, which is what we chose to do, which is you declare them and we encode them in some way. So when you declare a union type, we turn it into something else that can already be represented in the runtime today. That way, it'll work down level, it'll work with code that doesn't know about unions, that kind of stuff. So that's the path we took. Okay, so let's look at this example here. So we have, imagine dog, cat, bird, and shark are like completely unrelated types that just happen to exist. And some of them may be records, some of them not, some of them may be classes, some of them may be structs. They might even be interfaces, doesn't matter. They're types. And now we can declare a union type that we call pet here, which is 3 of those 4. So you can already see the benefit here of not letting sharks into your pet store or whatever. You get the strong typing means that we don't give up on compile time checking. On the contrary, we check it very strongly. And now, abstractly speaking, pet really means something that's either a dog, a cat, a bird. Okay? It's different from inheritance in many ways. So it's a really good supplement, I think, to inheritance. It's different both in that it can combine existing types. They don't have to like inherit from you in order to come together in one base type that can span them all. But it's also different in that it's closed. You can't have someone else inheriting and adding another type, another kind of pet. The person who declares pet is the person who decides the list of things that can be pet. So it's much more closed. There's an exhaustive list of things it can be, and that changes the point of control. That openness, sometimes just what you need in object-oriented programming, and sometimes you have to go bend over backwards to try to prevent people from doing that. And this is for when you're in that latter situation. Okay, so what can I do with a pet? Well, first of all, when something is a union type, the compiler has an implicit conversion from the case types, as we call them, the case types listed here, to the union type. So it's easy to create one. When I have one in my hand, I can do pattern matching on it, and I can use the case types as cases and get back to see, was it a dog, was it a cat, was it a bird? But also, if I go through all 3 of those, I don't get that annoying warning in the pattern match that says, oh, you forgot some other possibilities, right? It knows, the switch here is exhaustive because it knows the list is exhausted. You put all the things there. So you don't have to have a catch-all unless you don't have to, because there's not going to be any more different kinds of pets. So that's really all there is to the core feature. I will tell you a little bit more about how it works, how we plan for it to work. I'll first note that those of you who are, how many people here are used to, have tried discriminated unions in some other programming language? Okay. If discriminated unions that are often in functional languages, in those you declare each case not just as an existing type, but with a fresh name, and then one or more, or 0 or more pieces of data that goes along with it. And if you're like, well, how do I do my things? Well, that's easy with these because you can just declare the types right next to you can declare fresh types. So nothing is preventing you from having fresh types. Nothing here says that they have to exist in some other library somewhere. You can have your own, declare your case types just next to the union type. You can make them records with parameters if you like, and then they can deconstruct and everything like you used to from a functional language. You still get that expressiveness, you just have to write it a little differently. And we may even add syntactic sugar for that situation to make that easier if that turns out to be too clunky. Right? So you can still get your scenarios. How does it work? How do we plan on making it work? Well, I love this trick of having regions that I collapse and then it can pretend to be new syntax, but you can uncollapse it and see what it actually generates. So we plan to encode unions something like this. They're a struct, probably a record struct, so they have the right equality and so on. And they have a single field wrapped in a property that is the thing inside, either the dog, the cat, or the bird in this case. Just type that as object question even, because they can be null as well. And then there's a constructor for each of them. And that's all. That's pretty much all the structure there is. And so when we implement the behavior, this one here really, we just implemented by calling the right constructor for pet, the dog constructor in this case. And the switching, we implement by just applying the patterns to the value inside instead of to the thing itself. And that's really all there is. It's very low overhead kind of translation of it. And then the compiler additionally, like, here's that warning saying you didn't do all the things, and the compiler knows to remove that. That's just a compile time thing. So that's all a union is if you use the union syntax in C#. But we're also cognizant that there are already a lot of union types out there. A lot of people who have built their own union types to the best of their ability, despite C#'s lack of support for it. So you already have types that are union types. A whole popular library called OneOf, and an example of union types that somebody else wrote as a library and tried their best to work with the compiler and so on. And we don't want to just say, throw all that away and make union declarations instead. We want to be able for people to declare their own union types manually instead of using the syntax that we provide in the language. For various reasons. One of them, to have existing types be able to opt into the compiler's union semantics that I just described. So in fact, implementing this I-union interface is how you say, I want my type to behave like a union in C# now. And then there are certain expectations of how your internals work. We'll go and discover your case types from the constructors or whatever this ends up being, this pattern ends up exactly being. And the compiler will treat this, your handwritten union type, completely equally to the ones that are declared with the new union syntax. This also helps in another way, because if you have most people just have objects, and this is fine from a performance perspective, that there's a reference type field that they're stored in. But if you have a lot of value types and you care about performance a lot, you probably also care about the fact that then all those value types, like the struct down here, they get boxed. There's an allocation that happens. So we think that another scenario for hand-rolling your own is that you want to store things differently inside of the union type than what the compiler generates by default. Okay. Store them, like have multiple fields, one for each value type or whatever. And possibly someday the compiler would even have a mode where you can declare it to do that. but for now, you can roll your own that have the performance characteristics you want. So that's how we the union feature is really two parts. It's a completely open thing where all the union semantics come for everything that implements iUnion, and then it's the syntax that has a default that most people can use. So that's unions in C#. I don't have time to take questions because we just ran out of time, but I hope that'll be useful for you, and please find me after the talk and tell me what you think about this union thing and any concerns you have and any questions you have about it, okay? So I hope that's interesting to you. Hopefully this will be in C# 15. Maybe not, but hopefully. Until then, have fun with C#. Yeah, keep coding, keep having fun. Thank you.